Hi, I'm going to do some problems here for calculus. We have 2.5, number 8 from the online homework, and this corresponds to number 37 in the textbook. So it says find an equation of the tangent line to the graph at the given point. Okay, and the equation is x squared y squared minus 9x squared minus 4y squared equals 0, and the point is negative 4, 2 times the square root of 3. And this is the cruciform. That's the name of the graph it creates. Okay. And we're looking at negative 4, 2 times the square root of 3, so that's over here. Now, we want to do implicit differentiation, so the derivative with respect to x of x squared y squared minus the derivative with respect to x of 9x squared minus the derivative with respect to x of 4y squared equals the derivative with respect to x of 0. I realize the derivative with respect to x of 0 is 0, but I just want to balance do it to both sides so it doesn't confuse somebody. So over here on the left, what we have is a product going on, so we have to use the product rule. So that would be like x squared times that derivative of y squared is 2y, then y prime, plus the derivative of x squared is 2x times y squared. Now, why do we do the y prime? Well, as we talked about in this whole section, the issue is y is a function of x. We're taking the derivative with respect to x. We don't know what that function is, so we follow through with the y prime just as we would with the chain rule, that the outside function's derivative is a 2y, and we don't know what the inside function's derivative is, so we call it y prime. Okay, minus the derivative with respect to x of 9x squared is 18x, and the derivative with respect to x of 4y squared would be 4 times 2 is 8y times y prime, and that's equal to 0. So we're going to collect the y prime terms on the left side. So this is a y prime term. This is a y. I should do this other way. This is y prime term, and this is y prime term. So the other terms will go to the other side. I'll subtract 2xy squared and add 18x. And I'm going to write this as x squared times 2y y prime minus 8y y prime equals 18x minus 2x y squared. Now on the left side I can factor in a y prime, so y prime is going to be, or y prime times, x squared times 2y minus 8y equals 18x minus 2xy squared. And we'll divide both sides by x squared times 2y minus 8y. My stylus is kind of messing up on me today. X squared times 2xy squared. Nope. I read the wrong thing. Dividing by x squared times 2y minus 8y. So over here on the left, that divides out. We have y prime equals 18x minus 2xy squared divided by x squared times 2y minus 8y. So we'll plug in the given point. The point was, again, -4 times, comma 2 root 3. Okay, so let's plug this in. Y prime is equal to 18 times -4 minus 2x, no, sorry, 2 times -4, erase, 2 times -4 times 2 times the square root of 3 squared over, so x squared would be -4 squared times 2 times 2 root 3 minus 8 times 2 root 3. Okay, so what does it look like in the numerator? So I drop my calculators. 18 times -4 minus 2 times -4 times 2 times the square root of 3 squared gives me a numerator of 24. In the denominator we have what, -4 squared. That's 16 times 2 times 2 times the square root of 3 minus 8 times 2 times the square root of 3. That gives me 48 times the square root of 3. So 48 and 24, we can reduce that. That becomes 1 over 2. We have 1 over 2 times the square root of 3, and if we rationalize the denominator, we have the square root of 3 over 6. So with that, my computer's acting real slow right now. We do y minus 2 root 3 equals square root of 3 over 6 times x minus -4. So y minus 2 root 3 equals square root of 3 over 6 plus square root of 3 over 6 times 4 excuse me, is 2 root 3 over 3. And then I'm going to have, we have y minus 2 root 3 equals, I forgot my x again, square root of 3 over 6 plus 2 root 3 over 3. If I add 2 root 3 to both sides, I have y equals the square root of 3 over 6 times x, keep forgetting that x, plus, so this is 2/3 plus 2, so it's 2/3 plus 6/3 is 8/3 times the square root of 3. And that's that problem. I'm going to go ahead and look at the next one. I believe it's from the book. It's 2.6, number 39. Okay, so I'm going to say the magic words and have it all written down here. Okay, ready? Abracadabra, alakazam, make the problem appear right now. Boom, there it is. Okay. A fish is reeled in at a rate of 1 foot per second from a point 10 feet above the water. See the figure. At what rate is the angle between the line and the water changing when there is a total of 25 feet of line out? So what kind of relationship can we come up with between theta and x? Well, we have a right triangle there. Here's theta. There's opposite is 10 feet, and the hypotenuse is x. What function deals with opposite, the side opposite an angle and the hypotenuse? That's sine. Sine of theta is x, sorry, it's opposite, 10 over x. Okay. And we know that we're bringing it in at 1 foot per second, so the change of x with respect to time is getting shorter, is negative 1 foot per second. So the derivative with respect to time of sine theta is going to be the derivative with respect to time of 10 over x. So on the left side we have the derivative of sine theta is cosine theta times d theta dt, and let's see what is the angle changing, angle between the line and the water changing. So yeah, that's what we're after right there, is how this is changing here. Equals the derivative of 1 over x essentially is negative 1 times 1 over x squared dx dt. Now we want to solve for d theta dt. If we divide both sides by cosine of theta, divided by cosine, same thing as multiplying by 1 over cosine, which is of course secant theta. So our d theta dt is going to be negative 10 over x squared dx dt times secant theta. Now we'll put some numbers to this. We want to know when x is going to be 25. So our d theta dt is going to be negative 10 over 25 squared times negative 1, because our dx dt is negative 1, times secant theta. So the question is, what do we do about secant theta? We have all the other numbers we need. What about that secant theta? Well, let's go back to our triangle. In the triangle, what we had was x here, 10 here. What's this other side going to be? And here's our theta. Let's call this, for lack of a better term, a. A squared plus with 10 squared, which is 100, equals x squared. So a squared equals x squared minus 10 squared, or a squared equals x squared minus 100. Or a equals the square root of x squared minus 100. We're going to assume it's positive. So this becomes the square root of x squared minus 100. So that secant of theta is going to be the hypotenuse over the adjacent side, x over the square root of x squared minus 100. So d theta dt is negative 10 over 25 squared times negative 1 times x, which x is 25, over the square root of x squared, 25 squared, minus 100. So our d theta dt is going to be negative 10 over 625. I guess I can cancel those negatives. Negative 1 times that's positive, times 25 over the square root of 625 minus 100. And I guess I could reduce this 25 up on top and the 625 makes it 25 down below. So d theta dt is going to be 10 over 25 times 1 over the square root of 525. Let's see, the square root of 525, let's see what that comes out to be on my calculator. I think I might need this in exact mode. Nope, there, it's already in exact mode, okay. So this becomes 10 over 25 times 1 over 5 times the square root of 21. So with that, you have this 5 and this 10 can reduce to make that a 2, excuse me, and this is a 1. So you have 2 over 25 times the square root of 21. And if you want to rationalize that denominator, multiply by the square root of 21 over the square root of 21. So it's 2 root 21 over 25 times 21 is 525. And the decimal approximation for that would be 2 times the square root of 21 divided by 525. I get 0.017 radians per second. Okay, and that's how the angle is changing as it's being reeled in, and we're at 25 feet of line out. Okay, I hope that answers the question. Have a good day.